So at this point, you've got a little overview of streams. I talked very quickly about parallel streams, what it's doing under the hood. I showed you the example for the search with parallel stream, search stream program. And now we're going to start a section that will take us into next week that will talk about parallel streams internals. And you get a chance to learn more of what's going on underneath the hood. So I thought I would start by kind of giving you a quick tour of what we'll cover. And one of the key things we're going to focus on in this sections of slides is to know what you can change and what you can't change with parallel streams. So who cares, right? Why does this matter? Well, as you saw, it's often very simple to go from stream to parallel stream. That doesn't take much effort at all. It takes minuscule effort. But that doesn't always lead to a speed up. In particular, sometimes going from stream to parallel stream actually makes your program slow down, as counterintuitive as that may seem. And so you have to know something about what it's doing under the hood to know why you get these strange results. But more importantly, when performance matters and you want to get the most out of your multiprocessor, your multi-core processor, knowing how the streams framework works internally will make a big difference because you'll learn what you can customize and what you can't. And sometimes it helps just in terms of knowing how to debug your program. So just real quickly, let's recall the phases of a Java parallel stream. And this is obviously the same phases we talked about for a sequential stream, but there's a few differences. The split phase uses a splitterator, a parallel splitterator, to partition the stream elements up into multiple chunks. And under the hood, that's going to use the try-split method. We'll talk about try-split. You implemented try-split already, but you probably didn't think too much about what it was doing yet, because we'll cover that more when we do the parallel versions of stuff. The next phase is the apply phase. Apply for a parallel stream is going to take all the chunks, the atomic-sized chunks that the splitterator creates with try-split, and it's going to throw them in to the common fork join pool, and those things will then go ahead and run in parallel. Each one is sequential, but the collective results of them the collective effect will be to run them in parallel. And then the final phase is to combine everything together. So that involves joining these sub-results into a single result. Now, there's a couple of different variations here, depending on whether you have a concurrent collector or a non-concurrent collector. And we'll talk a lot more about that as we get further into this discussion. If you have a concurrent collector, then there really is no combined phase per se, because what's happening is as things are being applied, well, I should rephrase that. There's no final combined phase. What happens is the terminal operation will just accumulate things directly into a single synchronized mutable result container. And so it just accumulates them directly with no merging of intermediate results. So there's certain situations where that's a huge win, other situations where it's a lot of overkill, you don't need it. That's what concurrent collectors do. Non-concurrent collectors work a little bit more like I described here. They take each of the sub-results and they merge them together, they join them together. And so you'll end up with a single result at the end that comes from pairwise merging of sub-results into a final merged result. So you've got a chance to learn more about that stuff. And I think we'll also, just for fun, have you guys do an implementation that will use the concurrent collector semantics instead of the non-concurrent semantics. And to do that, you've probably been wondering, what is this synchronized array class that's been lurking around we really haven't talked much about in the course. We'll have you implement the synchronized array class, and that'll kind of show you how that all works. It's really pretty cool. I should also mention, by the way, when you watch the video for assignment 2C, keep in mind that we split the array splitterator out of the unsynchronized array class and put it in its own file. I mentioned this in the video, but just make sure you do that, otherwise you'll get strange results when your programs run the tests. So the trick here is to know which of these phases you can control and which ones you can't. As a general rule of thumb, you can control splitting quite nicely, you can control combining quite nicely, and you can control some aspects of applying. But applying has a lot fewer hooks to control than splitting and combining, and that's intentional. They're trying to use this cool common fork join pool to optimize the way in which the parallel processing takes place. So they deliberately didn't let you customize that very much, unless you were crazy enough to try to change the common fork join pool, which I don't even think you can do easily or portably. Okay, so that's just a quick introduction to parallel streams. We will talk through all those phases. You get a lot more insight, and you get a chance to play around with those things later.